Welcome to Repository education about how we can help you lower your total cost of ownership for backing up applications. In the example here, you can save up to 43 times space. You will also have an benefits of that you can have a better recovery time objective. That means that you can have more granular restore time. You can pick any time you would like. You will have also a faster restore. I will show you how that works. You will back up less data. So let's jump into the first example, how we can save data by using the backup models from IBM or Repository. For example, if you have a database in the size of 10 gigabyte, let's say that you save the backup to a local disk, for example C:. You do a full backup every day. That means that your 10 gigabyte here, the first backup will be saved on C:, and when the backup file system backup take backup of the system, those 10 gigabyte will be sent to the TSM server. The next day you save a new 10 gigabyte, overwrite the previous 10 gigabyte backup dump. Then when the file system backup protects the system, it will also save the new 10 gigabyte dump to TSM. So that's the next. So inside the TSM server now you have the latest 10 gigabyte dump from the database and also the previous one. So after 30 days you will have 300 gigabytes if the retention time is 30 days. 30 times 10 gigabyte will be 300 gigabyte. If you have multiple versions of the dump on C:, let's say that you keep the previous day on C:, then the dump will be the first dump will be of course 10 gigabyte on C:, and 10 gigabyte on also in TSM. Next day you will have 10 gigabyte from the previous day and then 10 gigabyte from the latest backup. That's 20 gigabyte on C:. Those 20 gigabyte will be stored in TSM, so plus the previous day, that's 30 gigabytes. So that will be more steep, the curve here. Note that those curves here is only reflecting the storage you need in the backup server. If you also consider that you store a local dump on C:, and only one version there, then you will have 10 gigabyte on C:, plus 10 gigabyte in TSM. That's 20 gigabyte just to dump database. What if you choose an IBM Tivoli Data Protector module or Repository Data Protector module? Then you can change the schedule how to protect the backup on the applications from once a day full backup to once a week, for example, an incremental and or transaction logs backup in between the full backups. So in this example you will have one full backup, of course. 10 gigabyte the first day. The next day you will take only the incremental or transactions from the previous day. And the curve here is very flat because of the scale here, but it's a small increase here. So after 7 days there will be a next backup, and that will in total space in TSM will be 10 gigabyte extra plus the incremental in between. So after 30 days you will have 1, 2, 3, 4, 5 full backups and little bit more extra because of the change ratio. So probably around 63 gigabyte of data between, depending on the change ratio. If you also turn on deduplication on the TSM server, and you can also do it on the client side with or without compression, then you will gain more space. The thing is that when you have a deduplication turned on, it can compare the full backups from this backup with other full backups from other system. You can also compare blocks that are the same as the previous full backup. So if you take a full backup the first day here, and you take a second full backup after 7 days, how much of the data has actually changed between the full backups? That is deduplication and technology that removes the duplicate information. It also compared with other databases. What we have seen is that MySQL data is very good to use with the deduplication and compression engine. You can remove about 65% or 80-90% of the data. So that's the green line here. So as you can see, if you compare the green line here with the blue line here, it's a lot of space to save. Even though you don't use the deduplication, you can save a lot of space here. And this is only the data that are in the backup system. If you also consider the data that you have stored on C:, it's more data to save. Okay, let's jump into backup window. Let's say that you are still doing a backup to C:. What if the backup of the database is running at 2200 an hour? It takes 2 hours to run the backup. It's finished at noon, 12. And the file system backup starts at 2300 hour and it finished at 1 o'clock. Are you sure that the backup that are saved on C:, is actually also saved in TSM? Well, you can't guarantee it. So that's why you need multiple versions of the backup stored on C:. So you can lose more than 1 day of data in case of emergency. So this is we call asynchronous backup. So of course you can set up the schedule a little bit more secure. so that you make sure that the backup starts at 8 o'clock 2000 hour in the evening and finish at 2200 hour 10 o'clock. And then the file system backup, you make sure that it starts at 2200 hour, but you have to manually monitor this so that it will not be a problem with corrupt backups. But as you can see here on the schedule here, it's a quite long process. The backup from MySQL, from that perspective to C:, is very, you can say, short because it's saved to C:, a local disk. But if you also consider the file system backup on the server, because a backup is not a backup unless you have moved the data to another location. If you also take that into consideration here, the backup progress window is very long compared to the previous one, but you are more secured here. What if you instead of using this method, doing a synchronous backup? A synchronous backup means that the data is sent directly from the application, from MySQL or SQL Server, to the backup server, in our case TSM. The backup window here can be longer or shorter depending on the resources. For example, if it is a 10 megabit Ethernet connection, of course the backup window from MySQL perspective can be longer. If it is a 10 gigabit in Ethernet connection instead, it can be shorter also because of that the target device can be faster than a local device. But if you take the whole picture of a backup from MySQL and also a file system backup, the backup progress window is much shorter. So here you will gain faster backup, but you will also have a faster restore. And that is also important. Now let's jump into another part of it, the recover point objective. That means how much data you can afford to lose in case of a disaster. Let's say that you would like to lose maximum 1 hour of backup of production data in case of a disaster. Then you can set up a schedule like this. So you take a backup every hour. But instead of taking a full backup, you can take incrementals or transaction log backups. And this window here, this slide here shows the schedule. If we jump into the because of its lower amount of data, the backup will be much shorter for the incremental. I forgot to mention that. Regarding the recover time objective, if you take a synchronous backup and compare with an asynchronous backup, the restore time is much shorter in case of a disaster. The reason for it is because of when you do if you take the lower slide here, you first have to do a file restore of the dump that you have saved on C:. And then when you have done that part, you need also to store all the incrementals and transaction logs from TSM file of it. And then you start MySQL or SQL Server restore from full, and then you continue incremental and etc. If you instead doing this directly from TSM, then you can do this in parallel, and you don't need to do a file restore to SQL first and then restore it to MySQL. You do it directly from TSM into the MySQL server or a SQL server if you prefer that database. Of course, there are other databases also that I didn't mention, but in our example, it's we have taken it from MySQL and SQL Server. So in this example, you restore the full backups directly from TSM, and then in a parallel, you do a restore of another database, third and fourth, and depending on how many parallelism you would like to have in the MySQL server or SQL server, the faster it can take to restore the data. And then in the parallel it restores also the transaction log and incremental backups. As you can see here, it's much shorter than the reversion when you do an asynchronous backup method or restore method. So an example here, restore the local backup files from TSM, the orange box here, C:. Restore incremental backups files from TSM, the green boxes. And restore the MySQL databases using the MySQL tool or SQL Server tool to restore the dumps from the file. And then you have to recover the database. That's the last step, the blue one. So by this example here, I hope you understand that you can save a lot of space by using repository utilities or other type of application protections such as TDP, Tivoli Data Protectors. You will also gain better recovery point objective, which means that you lose less data, it can be important for the business. Can do a more granular restore, can do point-in-time restore to whatever you like, if there are transaction logs enabled, and if, of course, it is supported by the application. The restore time, recovery time objective time it takes to restore the database will also be shorter, of course. So by this, the business needs is more easy to fulfill, and you save a lot of money for everything. So isn't this what you would like to have? So by this, I would like to say that you can download our product. We have a lot of data protectors: MySQL, Progress, OpenEdge, 4GL, Ingress, Interbase, Firebird SQL, Sybase Adaptive Server Enterprise, Sybase EQ, PostgreSQL, for many different type of operating system environments, such as Windows, Linux, on PowerPC, ZOS, x86, AIX, HP, UX, Sun. Please visit our page, company page, and download and test it for 30 days for free. If you'd like to have more information, send an email to info@repository.com. Thank you for listening. Bye.